Welcome to LNP Renewable System Integrators. Today we are going to see some of the basics of AC drives. So we are going to discuss what is AC drive. So why should we know about this AC drive? Where can we see these AC drives? How AC drives looks like, and what are the things we should know inside the AC drive? And most importantly, before entering into the topic, some of the basics we should know. What is the force? What is the torque? And what is the speed and the angular speed? What is acceleration, deceleration? What are the different ways of controlling the AC motor? And most importantly, the basics we are going to see. Apart from it, in the AC drive, while operating an AC motor, we are using other additional hardware components also. So if you see AC drive, this is how it's like. It has a converter part, it has a DC link, it has a inverter part. So with the help of these three things, okay, we are going to control the speed of a three-phase motor. Okay, with the help of so if you look into what is an AC drive, it is a device which used to control the speed of the AC motor, that controls loads ranging from pumps to fans and some complex machines also. Okay, so AC drive, how it will function? It functions by converting a constant AC frequency and the voltage into a variable frequency and the voltage. Okay, so where AC drives are used, it is used in conveyor systems, that is extrusion system, that is the cable manufacturing units. Okay, machine tools, metal forming industry, mixture and mills, packaging industry, printing and paper machines, pump, fans and compressors, heat ventilation, air conditioning systems, building automation system, textile industry, woodworking industry. Okay, we are using this. How it's look like, this is an example. I had provided the Siemens Dynamics as an example. So this is the range. Okay, like the okay, it is available from the small to the industrial range. And what are the advantage of this AC drives? So it is a low energy cost, it has a improved process control, it has increased productivity, very less maintenance. Okay, and we can use it for flow control devices also we can use, and low installation cost. Okay, so in all these advantage, each and every category, it has different controls. Okay, we can control speed, we can control flow, we can control pressure, we can control temperature, we can control acceleration, we can control tension, we can control the torque, we can monitor. Okay, these are the improved process control features of this AC drives. So as we know, we should know about the basic force is nothing but the push or a pull. Okay, so it can be caused by electromagnetism, gravity, or through the physical means. So if you see, okay, if you're giving a force of 10 pounds, okay, to 10 pounds, so it gets sum up into 20 pounds in the same direction. And if you give in the opposite direction, you're giving a power of 10 pounds in one direction and 5 pounds in the other direction, so the output will be 5 pounds. And if you're giving a 10 pound, okay, in the both 10 pounds in the opposite direction, the output will be 0. This is how a force will work. Okay, and most importantly, we should know about the torque. Torque is nothing but the twisting or turning force that causes an object to rotate. Okay, it is a product of force and the radius. See here, there is an example. Okay, you're going to apply the torque with the help of this rotating device. Okay, see here, at a 1 foot distance, if you provide a 10 pounds, okay, your output force will be only 10 pounds. But okay, if you provide, if you provide 10 pounds with a 2 feet distance, your torque will be 20. So this is how the torque is being calculated. Okay, and next we should know about the speed. If we take in if you consider in the linear motion, speed is the ratio of distance and the time. Okay, next is we need to know the angular speed. So how long it takes an operator to object to rotate at specified angular distance. Say for example, angular or rotational speed, if you consider, it is nothing but the distance by time. Okay, that is revolutions by time. Say for example, if you want to calculate an speed RPM of a motor, okay, how we can calculate? Simple. Okay, take a timer. Okay, mark at the one point. Okay, and see how many rotations it is making in 1 minute, then that is the RPM of that particular motor. Say for example, if it is making 10 revolutions in 1 minute, 10 RPM is the RPM of this angular speed of this motor. Okay, nowadays we have so many motors which is running with 500 rpm, 600 rpm, 1500 rpm, 2000 rpm, 3000, 5000, in even in 10,000 rpms the motors are running. Okay, so in this we need to know what is acceleration, deceleration. Very simple. If a device is operating in a 10 rpm speed, and if you, with the help of this frequency drive, you are increasing its speed to 20 rpm, then that is the acceleration. In the same way, with the help of this variable frequency drive, you are controlling a motor. Okay, it is running in a 20 rpm speed. You are reducing it to 10 rpm, then that is the deceleration. Decrease in the speed is deceleration, increase in the speed is the acceleration. Okay, and what are the law of inertia? Law of inertia states that an object tends to remain in its current state of rest or a motion unless acted upon by an external force. So if you want to know about work is nothing but the product of force into distance. Okay, if you want to know the power, it is nothing but the ratio of work and the time. Work is nothing but the product of force into distance. See here, there's an example. If you want to lift, okay, 1 pound object, okay, to a height of 1 feet, then what is the work that you have to make, force you have to make? Simple. It is a product of 1 pound force into the 1 feet distance. It is nothing but the 1. Okay, and if you want to calculate the same thing for a power means, so you already know the work, it is 1. Okay, and you're calculating for 1 second, then 1 by 1, that is nothing but the 1 is the power. Okay, and if you want to know, calculate the horsepower, so torque in pounds per feet into speed in rpm divided by 5252. And if you want to calculate the power in kilowatt, 0.746 into power in horsepower. Okay, if you want to calculate the horsepower, then nothing but 1.34 times of the power in the kilowatt. Okay, and we need to know what is a synchronous speed. Okay, so based on the number of poles, we can increase the synchronous speed, that is nothing but an rpm of a motor. Okay, say for example, the formula is 120 f by p. If you have a frequency of 60 hertz, and if you have a number of poles 2, then its rpm is 3600. Like this, by increasing the number of poles with the same frequency, we can increase the speed of these efficiency of these motors. Okay, now we need to know the slips also. It is nothing but the difference of synchronous speed and the motor speed divided by synchronous speed. Okay, this is how the slip is being calculated for any sort of motors. Okay, and we can control the motors in different ways. One is through the direct starter. In one direction we can operate. If you want to operate a motor both in the forward and the reverse with the help of a two direction reversing starter, you can control it. And if you want to do the forwarding, okay, with the one set speed, we want to do the acceleration as well as the deceleration, and you want to do forward as well as reverse, then you can go for the soft starters. Otherwise, with the help of this variable frequency drive, okay, you can run a AC motor in any direction, both forward as well as reverse. You can increase its speed, you can increase its ramp. Okay, you have the additional functions. So that is the facility of this using the normal AC drives. Okay, so this gives an answer why we are going for AC drive. If you go for a direct starter, you can operate in one direction. If you use a reverse starter, you can operate in two directions. If you go for a soft starter, you can operate in two speeds. Okay, acceleration as well as a deceleration. In both the directions you can do. But if you go for a variable frequency drive, you can operate in two directions. You can go for variable speed and the ramp. Okay, and you can go for additional functions also. That is the benefit of this. And if we can calculate the load characteristics of these motors. Okay, based on that, based on our applications, okay, we can classify it based on the, if you calculate the torque and the speed. Okay, if you calculate the load characteristic for the any motors based on our application, if you see, if your motor is operating with a variable torque, okay, you can use that motor for pump and fan applications, because this one, how it will work, when the load increases, speed also increases. Okay, whereas a constant torque, it means the load is essentially the same throughout the speed range. This we can use for conveyors, hoisting gears. Okay, if you want a constant horsepower, then the load decreases as the speed increases. This you can use for winders, rotatory cutting machines. So how the basic AC circuit looks like. See here, we are taking a AC power. This converter is converting that AC into DC power. With the help of this DC link, we are passing it through the inverter, and with the help of the CPUs we are controlling the speed of these inverters. At last our motor is getting operated in the variable frequency with the help of this AC drive circuit. So basically we want to know about the diode. Diode is nothing but a device which conducts in one direction. It has an anode, it has a cathode. See here, there is an example. We are providing AC supply. If you connect a diode in and we are connecting a load in it, so only in the halfway rectified DC output you can see. And if in the same way if you reverse it, okay, it will be in the reverse direction. So yeah, as we saw earlier, the converter will convert a AC into a DC. Okay, but still, if we didn't add any sort of capacitors, now the DC will be like this only. Okay, if you want a clear-cut DC output, for that purpose we are using this capacitors. So nowadays in the inverter, okay, instead of diodes, we are using a SCR. That is nothing but the thyristor. It has an anode as well as a cathode. By controlling the voltage in the gate side, okay, you can increase, you can make it to act like a switch. Okay. In the same way, if you go for IGBT, it has a gate, collectors, emitters. And also why we are going for this freewheeling diode? Very simple. So with the help of this gate, emitter and the collector circuit, we can control the frequency of this variable frequency drives. And also if you are having a motor, okay, which is overhauling, okay, sometimes there is a possibility for it to act as a generator and provide a reverse voltage. So in such occasions it will damage your transistors. So to prevent that, we are using this freewheeling diode, so that the power output will be in only one direction. That is a specialty of using this freewheeling diodes. So pulse width modulation, this is how it works. Okay, at any speed, at any point of time, you can control the um, uh, speed of this vehicle, our drives. Okay, what are the hardware components that normally we use for this AC drive system? We need to have a AC supply first, then we need to have a circuit breaker or a fusing system, and we should have a input contactors, we should have a EMNC filters, and we can have a input line reactors. Okay, and we have a sinusoidal voltage filters, output reactors. At last we can use for this induction motors. But apart from it, okay, it will have a control unit, power module, braking chopper, braking resistors, operating panel, input and output modules. Okay, so we can go for multi-axis configuration also. In a single axis configuration, you will have a one converter, DC link, and one inverter. It will directly connect to the motor. If you go for a multi-axis configuration, that is the industrial purpose, you will have a single converter, but through the DC bus, okay, we will get connected it into different inverters. So AC drive operation, we already know it. For a driving purpose, what is the torque and the speed that you have to apply. For the rotation purpose, how the energy flows will be. Okay, when the regeneration is happening, what will be the direction of flow of energy has been shown in this figure. And if you are going for a dynamic braking, with the help of this pulsed resistor, you can do the braking operation. Okay, these are some of the examples of regenerative capable single axis AC drive example, and this is a common DC bus in the regeneration process flow directions. Okay, during the normal DC current flow, during the regeneration, how it works. So both the things you can see here. Thank you so much. So to learn more, to know more, please subscribe. Okay, and if you want to do projects with us, you can contact us. We have provided contact details in it. We are providing design, installation, testing and commissioning, training supports for the industrial automation, building automation, home automation projects with the help of these PLCs and SCADA systems. And if you want to do solar power projects for the on-grid and off-grid, we are providing. So feel free to contact us. Thank you.